got you, Mountain Dew.
Alright, so first guy, go up and deal with the reactants. Second guy, go up and deal with the products. First guy will be John Lupo. Second guy will be Gary Tang. When is basketball playing now?
76.
So that's like a week from next Friday, something like that. Thursday, a week from Thursday. Okay, that makes sense because the quarter is on the 20th, and that would be Friday. So yeah.
I think you guys have a matchup. I think like swimming, wrestling, and basketball. Or swimming, wrestling.
We may.
Hockey all the
Might be fun.
We don't. We're lucky. We don't. We're on Wednesday and Saturday. So I make a deal that I tell all wrestlers you have to that's one.
There's so many people in like during the
Is opening night that night?
Single out.
Yeah, you take the chart. The McDonald's.
Yep.
Right, and then just one element is
Yep.
grades. That's
Although
the
it's like
grades.
on the Holocaust night,
At
H2.
Okay.
No charge, that's still 0.
That's 0.
But
Dude,
if it's H2 like -1 or -2.
That'd be a hard one because it would be you know what I mean?
But I feel
Oh,
like
yeah,
you practice
you see what I'm saying.
because like
So
people.
if it's like H2,
I didn't know.
each one would be close. Okay, what's your rule for O? How are you, Mike?
I'm 26 on there.
Good. And lunch. No boys out. Set. Yeah.
Wrestling's such a gnarly sport.
Yeah.
Like, let's starve a couple dudes for a week or two and then watch them fight.
Oxygen's -2. Okay, now, sodium we got a problem with, but let's think about this. Guys, think about this logically for a second, okay? Right now, when we look at this, we don't have a rule specifically about NA or BI, okay? Now, bismuth, if we go to bismuth here on the periodic table, let's see, bismuth's right here, it's got multiple oxidation states. So we can't know that one for sure just by itself. Okay? So if we go to sodium, sodium only has two possibilities. If it's pure sodium, it would be what oxidation state? No, if it's pure sodium, elemental.
0.
It would be 0. Okay. The only other thing could be if it's in group 1. It's got to be +1. So there's only two possibilities for sodium because there's only one oxidation state. So 1, remember, it can be 0 or 1. 0 if it's an element. It would only be 0 if it was just Na, just Na no charge. No, because they all got to add up. Okay, what do they all got to add up to? They got to add up to 0 because there's no charge up here. So right now, what's this add up to?
5. Or no, 1.
What? What's that multiply up to?
-6.
-6. That makes the total now.
5.
-5, so that must be +1. Okay. So how about, next down here, how about John Vergatz, you tell us what's being oxidized, and Jarrell Hicks, you tell us what's being reduced. And you do your little connect the arrow thing. Here's a night too. Yeah, I just got it. Yeah.
You want me to read it out too, or just solid?
You could just connect up. Okay, 5-3, okay, good. Yeah. Okay, so oxidation. Element oxidation involves what? Oxidation involves oil ring. Okay, so think about it. If you are oxidized, you lose negative charges, becoming more positive.
So
2 to 7, yeah. 2 is getting more positive as it goes to 7. So we're connecting the same element and it's changing its state.
Can you show us like the agents and stuff?
We're gonna do that. Yep.
NABIO is the
Okay, now the only thing, John, I'd be critical of is you ate up a lot of space by going that way, and remember, we might need that space down there, so. Now, for you guys, it probably won't be an issue on the test because you got the whole page, okay? You'll have a lot of space to do these. But here on the board, it does make a difference. Now, as far as, you said, can we identify what's oxidized, what's reduced? Do you see we can already see what's oxidized? Mn is oxidized, right? Mn plus 2 in particular. What's being reduced? Bi plus 5 is being reduced. Okay, we'll write that out at the end. But the thing that's being oxidized and reduced is the thing that's actually circled on this side of the equation. This is oxidized. This Bi plus 5 is reduced.
That'll be the reactant.
Yeah, it's got to be a reactant. Yep. Then we'll get to the oxidation reduction. What are the oxidizing agents and reduction? Okay, race. Get us the next part for the oxidation, and Rob Harris the next part for the reduction.
I'm Rob.
Alright, so we connected our things, that's good. Okay. Joe DeMarco, what do we do next? What? No, you're getting very vague here. Specifically, what do you got now?
Everything but H and OH.
There you go. H and O.
Okay.
So will you do that for the first reaction?
What? Oh yeah, it's already balanced.
It's already balanced, right? Because you got an Mn here and an Mn here. Okay. Now for the second reaction, Liam, you got a tough job. What do you have to balance? No, over here. We're gonna balance things other than hydrogen and oxygen. So we're gonna ignore this oxygen, right? Are your BIs okay?
Yeah. Oh, you can put an NA on.
You have to put in Na. Now the question becomes, are you going to put in Na or are you going to put in Na plus? You think say no?
NA plus because it's already in the equation.
It's Na plus 1 because it's already in the equation is one way to look at it. Another way to look at it is this, and this is something you may or may not know. But if you take pure sodium and throw it in water, do you know what it does?
It explodes.
It explodes. It catches on fire. Okay, that's because it turns into Na plus, and that's partly why I don't keep that stuff around here. Because all I can think is the day before, like a rival McDowell game, somebody's stealing my big chunk of sodium and finding somebody's swimming pool and chucking it in there.
That actually amazing. That'd be amazing.
It would be until the cops showed up.
Would it like make a?
Do anything to the water?
It'd make it slightly acidic.
How big of an explosion?
Depends on how much sodium and how much surface area.
Wow.
Like a basketball block of sodium.
That's a lot. That's a lot. It's not, and the thing is, it's not going to be like necessarily kaboom. It's just going to be more like, I don't know with that much. I'll put it this way. When I did it in college, like first you have to store it under mineral oil. If you have pure sodium and you were just set it on the counter here, it would catch on fire here because there's moisture in the air. So you have to store it under a layer of something where water can't get to it, usually mineral oil. We took a little pea-sized piece, about the size of a pea, and we put it in a test tube about that big with about that much water in it. And first it caught on fire and it like crazy. It was caught on fire under the water, but eventually it cracked the test tube too. So like, I mean, it gets really, really hot, and that's just a little pea size. Now, if you really want to make it really, really, really bad, or good, depending on what your perspective is, instead of throwing it in a whole basketball size, take that basketball and separate it all up into pea sizes. Because now you have a lot of surface area, you throw that in there and they all react. Whereas if you throw a basketball size thing in, only the surface area is reacting, so it'll take a little longer. But
How
if
much
it's
is this stuff?
What's that?
How much is this?
You can't get your hands on it. It's kind of hard for you.
Is it like illegal and stuff?
It's legal, but they just don't let people have it because it's so dangerous. I mean, think about it. If you don't know what you're doing and you don't store it right in a place like this, the place burns down. You know what I'm saying? It just spontaneously reacts. You know. This is partly why, if you ever notice in chemistry labs, if you look around, they don't have sprinkler systems on purpose, because sometimes the fire can be caused by a sprinkler system. You know what I'm saying?
That'd be so bad.
Isn't that interesting? I'm sure somebody learned the hard way at some point. That's probably why it's part of
So
resident
would they
law.
use fire extinguisher?
Yeah, yeah. Sure.
Wait, so could you just do it with like a sodium ingot?
Yeah, with it like an ingot of sodium, yeah.
You can buy it on Amazon.
Can you? You can do it.
Let me see.
How much?
Now, if you guys go do that and you say your teacher did it, I'm like,
What would happen if you ate some sodium?
it'll catch on fire in your mouth. Yeah, I know, I caught it on tape.
Yeah, it's
I'm already caught it on tape, I know. That's all right.
150 bucks.
So here's, okay.
138
So watch. So here's what's gonna happen. If you guys do that, you're gonna go onto the newspaper and you're gonna see a picture of me like this.
Boy.
Okay. All right, so let's get back to the moral here. You guys understand that figuring out what form of sodium is important. Because you realize that's affecting charge. And that's something eventually that's gonna become an issue. So when you're not sure, I would always say, whenever you're gonna bring something in that's not on one side of the equation, look to the other side and see what's there. Well, I see Na, but still, I might be tempted to just say Na, but if I think a little deeper, this Na was a +1 over here. So it's probably gonna be the same thing over here. Because it's not part of the oxidation reduction. Okay, Chris Malek, what do we do next after we balance elements other than hydrogen and oxygen?
We balance oxygen using H2O.
Okay, and would you do that for the first one, please? Ah, he has to. And how about for Andy Burns? Can you do that for the second one, please? So balance things, balancing oxygen using water. What did it say about the Amazon? What did they tell you?
You can buy it like 130 bucks a pound.
$130 a pound?
How much for the pound then?
That'd be a lot. I mean, it'd probably be a good chunk like this.
What pound is how many grams?
454.
Pretty good.
So does it say anything else about it, like shipping or anything like that?
It's $5 for shipping from Shop Your Own.
Where's that in your?
What about the on Amazon
Is it on
Prime?
Amazon
Prime?
Prime?
Maybe. Maybe we'll do
Free
that.
2-day shipping.
Free 2 days
About to buy
shipping.
these
Maybe we'll do it next year, or at the end of the year when we do like thermite. Maybe we'll take a big thing and get a big pool of stuff and throw it in there. Maybe.
Here?
No, outside the bar.
Yeah, like in a baby pool.
That'd be awesome.
Yeah. Did you guys see that last year when we did thermite?
I saw a video. It was on a bunch of people's Snapchat stories.
Yeah, but I'm not gonna.
Yeah, is it true?
Yeah. No, if you guys didn't see last year, if you guys wanted to do something fun, so we made what's called thermite. And thermite is you mix aluminum powder and rust powder together, and you have to get something to get hot enough to start it. We use little sparklers, like 4th of July sparklers, to get it started. And once it started, it's a really rapid, fast reaction. You make molten iron. So we made molten iron out of spark plug. It just flashes red, and it gets to be like something like 4,000 degrees Celsius or something like that. I mean, it gets really freaking hot. It's a reaction they use to weld together railroad ties or railroad rails. You know how they're all one continuous rail? They don't come that way. They have to weld them together. So they weld them doing this reaction. Okay, so let's see. We can do well. Okay, so we brought in 4 H2Os here to bring in